everybody. In this section, we'll be talking about the differences between linear, quadratic, and exponential functions, which we're going to talk about what the equations look like as well as what the graphs look like. And after I go over this, you guys will complete just a nifty activity to just further explore different graphs and equations that are in these formats. Okay, so let's talk about what the equations look like when we have a linear, exponential, or quadratic function. So linear, okay, linear, what the graph actually looks like, it's kind of in the name. Do you guys see the word line? Okay, so linear means a line will form, but the equation is something different, so we need to talk about that. So when you have a linear function, the highest exponent is going to be 1. Okay, which we have to be careful with this because usually when we have an exponent of 1, remember mathematicians tend to be lazy and we leave off the 1. So it will secretly be there, it just won't be listed. Like for example, y equals 2 to the x, or 2x to the first power. Okay, so I don't see a first power, but technically there is a secret 1 hanging out with my x. Okay, and then this term does not contain an x, so technically the highest exponent is x to the 0, because if you remember, anything to the 0 power is a 1. So on this one, your highest exponent is x to the first. Same with this one, the highest exponent that you see in each term is x to the first. Okay, so we're looking at the power of x and we're determining what your highest exponent is. So if you have a linear function, the highest exponent is always going to be a 1. And your standard form for a linear function is that nifty y equals mx plus b, which you've probably heard a billion times. Okay, now exponential, these are the functions that we've been talking about in this entire unit. So remember, again, it's kind of in the name of the function that kind of gives you a hint as to what the equation will look like. So exponential, okay, if you guys see the word exponent in the word exponential, well, I promise you that is not a coincidence. Sorry, guys. So when you see that, okay, when we have an exponential function, the exponent is always going to be an x. So your variable is going to be in the exponent of an exponential. So it has x as its exponent. So you guys have seen these. We're exponential pros. So examples are like 2 to the x power, or y equals 3 times 1/2 to the x power. So in this case, your exponent is going to have the x. Okay? And your standard form is that y equals a times c to the x, which you guys have seen before in this unit. Okay, now a quadratic. Okay, a quadratic, that's when your highest exponent is going to be a 2. Okay, like so for example in this one, this term, again, we're looking at the exponent on the x. Okay, so this term has an exponent of 2. This term I don't see an exponent, so secretly in the exponent is a 1. And this one doesn't even have an x, which technically means its exponent is 0. So the highest exponent is 2. Same with this one. X squared is also quadratic, and the highest exponent is 2. Okay, and your standard form of a quadratic is ax squared plus bx plus c. Okay. Now let's talk about some quadratic, exponential, and linear graphs. So, I already kind of gave away what a linear function's graph looks like. It's in the name. Do you guys see the word line? Line. Okay, linear means a line. So it's a straight line, which looks something like this. Okay? Now, an exponential function, this is a function that rises or falls very, very quickly. Okay, exponential graphs are going to be your graphs that either grow or decay the quickest. Like they're going to grow faster than a linear or quadratic graph. Okay, they grow or decay or decrease the fastest out of any graph we're going to talk about. So if you're ever asked a question about like which function is going to grow the fastest, well, it's always going to be exponential. Exponentials grow or decay very, very, very quickly. Okay? Also, guys, don't forget exponential graphs are a little different because they contain an asymptote, so just be aware of that. So this is an example of an exponential graph, which you guys have seen before in this unit. Okay, lastly, a quadratic. You probably know the shape of this graph, but it makes like a U shape. It's also called a parabola. So this is what a quadratic graph looks like. Okay, so now that I've kind of gone over what some of these graphs look like, you guys will be completing activity just to let me know, like, if you understand the concepts between linear, quadratic, and exponential. So if you click on, again, go to the announcements link on your homepage, click on the /15 assignments. Okay, and if you guys see here, it says in our final section of Unit 2, you'll be comparing the differences in data, equations, and graphs for linear, quadratic, and exponential functions. Watch the video below, which is this video, and then complete the activity to apply what you learned. Don't forget, this activity is only being graded for completion, so I just want you to give your best effort. Guys, so this is the video that you are watching right now, so you already clicked on that. Now, this link will take you to the activity. It's going to take you to a wiser.me activity, which I'm going to log out just so you guys can see what that looks like. Okay. So I'm going to click on it again so you guys can see what it looks like to log in. Guys, so whenever I log in, I personally always sign in with Google. Okay, and again, you can just pick your school account. Usually that's the easiest. And after that, it'll take you straight to the worksheet. Okay, so you're just going to apply what I taught you in this video. Again, none of it counts for a grade. The first 3 questions are just multiple choice. You just select like which one you think is the right answer. Okay? The next one you are matching. So you're going to match the equation to the correct function, which some of these I gave you some tips what you need to do first to figure out which function will match to. Like in this one you need to solve for y first. In this one you need to distribute. So multiply like the x to both terms and the 1 to both terms. And then you just simply drag it to whichever one you think it is. Okay? And then the final one, or no, JKLOL, not the final one. On this one, you're just telling me what the graphs look like or describing the shape. So like the U-shaped parabola, like if you think that's a linear graph, you click on linear. If you think the straight line is quadratic, you click on that. Okay, and if you think this one is exponential, you click on that. Okay, and then lastly, you are just labeling. It says determine whether the following graphs are linear, quadratic, exponential, or neither. So you just click on the graph and type which one. Like if you think this is linear, you type linear. If you think this one is none of the graphs, you type neither. Okay, this one, if you think it's exponential or something, you type that. And then this one, if you think it's, I can't remember what I've used already. Linear. If you think it's like quadratic, I don't think I've used quadratic, you type quadratic. Okay, and then after it, you just hand in your work, which will tell you now's a good time to go over your answers. And then after that, you just confirm and hand in your work. Okay, so that's all you're doing. I hope you enjoy the activity. After that, you'll continue on like we normally do. So after this, you will just be watching the rest of the videos in this unit. So let me know if you need any help. Again, this is only for completion, so just give me your best effort.